Assalamu alaikum my dear brothers and sisters. Once again welcome you all to my YouTube channel Let's Join Pharmacy. Today I am here in front of you to discuss about one more very important question in 5 mark, that is POC. That question is the basic character of amines, okay, or basicity of the amines. Okay, this question definitely will ask in your examination. So be thorough with this question with the answer. Got it? Let's discuss. See, a basic character of amines means, as you know, that basicity means these are the compounds which will receive the proton, and increases their basic character. As usual, amines are basic in nature. It is a type of a chemical property. Mainly the basicity of the amines, it is a chemical nature of these amines. And amines are basic in nature. Yes, absolutely basic in nature. Why they are basic? Let's discuss. They can accept a proton from water and can form water soluble salts with mineral acid. Means why they are known as basic means they will accept a proton, they will receive a proton from water molecule and they form the water soluble salts with some of the mineral acids. Then they are stronger bases than water. Why means reason is there, I will tell you, but much weaker bases than hydroxide ions or alkoxide ion. Okay, they are stronger bases than water and they are weaker bases than hydroxide ions or alkoxide ions. Their basic nature is due to, here is the answer, why these are strong bases, why we are calling them as a very strong bases means here, the basic nature is due to the availability of the lone pair of electrons on nitrogen. This is the main intellectual spirit of this nitrogen. Okay, because of the presence of a nitrogen, because nitrogen carries a lone pair of electrons. Due to that, they are stronger bases than water. See here, you are observing 2 dots on the N. Okay, these dots are not a simple dot, they are lone pairs. One lone pair are present on top of the nitrogen. They play a very important role in every reaction in the human body. Not only in the human body, in chemistry. You remember these 3 important compounds. One is nitrogen, oxygen and carbon. Okay, these 3 such compounds I will tell you, my dear brothers and sisters, without these compounds the chemical process cannot be proceed. Very important compounds in the periodic table: nitrogen, oxygen and carbon. Okay, now including the hydrogen also. Okay, many drugs, many diagnostic treatments, then many electrical applications are used by means of these 4: nitrogen, oxygen, then hydrogen, got it, carbon, allotropes, many very important role of this carbon. Okay, we have studied in your 10 plus 2. Let's discuss here today's history of this basicity. See here, as you are looking there, when the amine, primary amine made to react with HCl, there will be formation of the NH3 plus Cl minus. Means simple. Why I will there will formation plus means these will receive the proton from the HCl. Okay, and the lone pairs turn into plus and these is Cl minus. Got it? See here, one more example. This is the primary amine. When react with water, from these water, this NH2 will receive one proton and it form NH3. Directly come here. Okay, they form RNH3 with the formation of a hydroxide ion. Okay, hydroxide ion. And the hydroxide, OH minus and alkoxide, they are more bases than the nitrogen. Okay, than the nitrogen. Got it? You practice these reactions. This is some description on the basicity of the amine. Now let's discuss. On the basis of these 3 subheadings, we can discuss the basicity of the amines, actual basicity. First one is aliphatic amines are stronger bases than ammonia. Means these aliphatic amines, they are stronger bases. Okay, stronger bases than the ammonia. When we compare to the NH3 group, these aliphatic amines are more strong. How means? Let's start. First we will study these 3. Basicity of primary, secondary and tertiary aliphatic amines. Aromatic amines are weaker bases than aliphatic amines and ammonia. First we will study about aliphatic amines. That's first one, are stronger bases than the ammonia. Got it? Now see, the basic nature of the ammonia and amines, is due to the presence of an unshared pair of electrons or nitrogen. Got it? One lone pair of electrons are present on the top of the nitrogen. Okay, due to this the basic nature. Got it? Now the second point, you remember the points. Okay, no, not necessary to remember the dit to dit points. Point to point you don't remember, just you concentrate on what I am reading. Concentrate, don't by heart. If you by heart means everything will be vanishes. Just understand the concept. Why the basic character? Because of presence of lone pairs of electron, one lone pair of electron on top of the nitrogen. You remember this much. Then aliphatic amines are stronger bases, okay, than the ammonia. Why means, see, because of electron releasing inductive effect of alkyl group. Yes, this is very important. Okay, why the aliphatic amines are stronger than the normal ammonia means due to the inductive effect. How sir, how you will tell that due to the inductive effect? What is this inductive effect? We want this. Yes, let's study. Such an alkyl group is electron releasing. Means this aliphatic amines, what happens here in aliphatic amines, these aliphatic amines means this is the aliphatic amine, this is the aliphatic amine, this is the ammonia. Okay, these aliphatic amines, what they will do, they will release the electron. By releasing the electron, what happens, the electron density over the nitrogen increases. Due to the electron density increases on the nitrogen, the electron pair means the sharing of electron becomes increases, or the greater in sharing of electrons. Got it? This is the main reason why these aliphatic amines are stronger bases than the ammonia, normal amines and ammonia. Got it? This is the amine you are looking. Now I will read the descriptions here. Such an alkyl group is electron releasing. Alkyl group, it is electron releasing, increases the electron density over the nitrogen. Understand what I am saying? Increases the electron density over the nitrogen and makes the electron pair more availability for the sharing. More availability for the sharing. Now see, NS3, there is no alkyl group, so less electron sharing, less available for sharing electron pair. Here one primary amine, so there is some greater amount of sharing of electrons where in the primary amine when compared to this normal amine. Then in secondary it is better, greater than this primary amine. Okay, greater than this primary amine. Ammonia is less than primary amine is less than secondary amine. This is the inductive effect. Okay, this is the character of the aliphatic amines are stronger bases than the ammonia. R releases electron, make the electron pair more available. These are what you are looking now. They will releases the electrons. So the density over the electron increases. Due to the electron density increases over the nitrogen, the sharing of electrons increases and the stability also increases. This is the simple basic one character of these amines. Now basicity of a primary, secondary and tertiary amines. Basicity of primary, secondary and tertiary aliphatic amines. See here, secondary amines is greater than primary amine is greater than tertiary amine. Here a little the product will be ulta, inverted, where we studied in the previous character, that is aliphatic amines having the greater basic character than the ammonia or amines. Why means because there is a increase in inductive effect. Induction means the alkyl group produces the greater amount of inductive effect, but here no inductive effect. Yes, absolutely inductive effect, 50% inductive effect, 50% is a solvation effect. No need to remember what is this solvation, what is this inductive. Just remember these are the two effects which are very important to increase the basic character of these amines. So remember this much. Okay, in the higher classes, that is in 4th sem, 5th sem, 3rd sem, you will study in detail what is this inductive solvation effect. A secondary amine having greater character means having greater basicity than the primary amine. Primary amine having greater basicity than the tertiary amine. I have told you before studying the reactions of the amines that tertiary amines won't play a role with the nitrous acid. Okay, if you are new to this video, then first go and watch that video. Okay, so that's why tertiary amine is less base than the primary amine. This mechanism is due compared with the inductive effect and solvation effect. Now the third character of the basicity, that is aromatic amine. Benzene amines are weaker bases than the aliphatic amines and ammonia. Why they are weaker bases than aliphatic amines and ammonia? Let's study. The weaker basic nature of aromatic amines, benzene amines, compared to the aliphatic amines is explained in the next page. Please turn open. Don't go, don't quit. See, very important, very interesting resonance structures you are understanding. You are looking here on the on your screen. Yes, aniline is a resonance hybrid of the following contributing structure 1 to 4. Okay, 1 to 5. Aniline, it is the resonance hybrid structure from the structure 1 to 5. See here, the electron pair on the nitrogen atom conjugates within the ring and it has a 3 resonance forms. 2, 3, 4. These are the 3 resonance structures are formed. Why? Because of delocalization of the electrons. What is the resonance? Resonance or conjugation means just delocalization of the electrons. Changing of the electrons from one place to another. Transport of the electrons is nothing but resonance structure. Resonance also a very important role plays in the basicity of the amines. Got it? Now due to this, what happens? The electron pair is less available for protonation with an acid. See here, I will explain you, don't worry, just you first understand this. Due to this means due to the transfer of electrons, what happens? The electron pair is less available for the protonation, okay, with an acid. They cannot give the H plus or they cannot receive the H plus, and also decreases the density over the nitrogen. Why? Because of this transfer of electrons, because of this resonance. Thus aniline is less basic than aliphatic amines, in which no such type of resonance exists. See, because why here aniline is less basic than the aliphatic amine means because of the resonance. Do you observe in aliphatic amines, is there any resonance? Here is there any resonance, you tell me? NH2, then R, N, R, R. Is there any resonance here? It is the aliphatic amine. It is a secondary amine. It is a tertiary amine. Is there any resonance here? No. Due to the no resonance, what happens? These aliphatic amines shows greater basic character than the which one? Aromatic. Why means these here lone pair of electrons, what happens? Due to not delocalization, the basicity will increases here. Here also the basicity will be increases, means the density of the electrons increases here. But in aromatic, what happens? There will be no increase in density, because what happens? The structure to structure, these lone pairs will transfers. If the lone pairs get the transfers, means the density also transfers. If the density transfers, means the basic character decreases. This is the simple concept, my dear brothers and my dear sisters. Now see, this is the beautiful structures. Now it is the aniline. Benzene attached to NH2 group. Here N contain 2 lone pairs of electrons. Now what happens? These 2 lone pairs are transferred to here. Decrease in basic character. Decrease in density from N. Now these N will form the double bond plus charge. Okay, double bond plus charge. Now again from here the bond will be shifted to here. See, the same NH2 double bond. The shifted bond here. Basic character. Now again what happens? The lone pair of electrons again they shifted here. See, NH2, the lone pair of electrons they shifted here and bond is formed here. Here one bond, and this bond what you are looking now, that bond will convert it into lone pair. Again these lone pairs will transfer here. Got it? See, you are observing the lone pair will transfer here. Yes, and this bond what you are observing now, this bond will form the one lone pair of electrons. This bond is as usual same. Again these will transfer here. Formation of this bond here. At last same aniline is formed. Here this delocalization of the electrons, what they will do, they will decreases the electron density over the nitrogen. So that's the reason the aniline, these structures why I taken means to understand the concept. Okay, and these structures you have to write. You have to write, my dear brothers and sisters, for the better explanation. Okay, you have to write this. For this reason, the aniline or the aromatic amines shows less basic character than the aliphatic amines or ammonia. Yes, this is your today's concept, my dear brothers and sisters. Yes, inshallah in upcoming classes we will discuss about the next concept. Thank you for watching this video. Assalamu alaikum.